Already did it. All right, so let's go ahead then and look at how to solve that. You guys are pretty good at these now. We've done them for a while, watched me do them. So see what you can do with this one in separating it. I want, let's change this to time, if you don't mind, because that is the variable, right here, the independent variable. We're changing population with respect to time. And that's what we use down here. So let's do it as well. I'm going to erase all this while you try to separate the t's and the p's. The L is just a constant. It's given in the problem. So don't worry about that one. It can go on either side as a constant can. So see what you can do with getting the t's on one side and the p's on the other.
Dramatic pause.
Yeah, oh yeah, we've got Jonathan hanging there. Jonathan, you try it too. Is it working? All right, let's see what we're coming up with. I'll make some room to work over here. So let's see.
I don't know what to do.
Was it very separable?
I did a differential quench.
All right, let's see if it was or it wasn't.
Can we have that?
All right, we're starting out with the change in population with respect to time is Kp times this new friend, P over L, where L is a constant.
Oh,
So-
I forgot to put that.
Hubba hubba.
All right, did it separate for you, Erin, with anything?
Sort of. Like I divided by Kp and then I multiplied by dt.
And
The
then-
other side.
Hubba hubba.
all right, so you divided by Kp
Yeah.
and at the same time, so that's gone, and you multiplied by dt.
Yeah.
All right, so is that completely separated?
No. Oh yeah, it is. But it's, no, it's not.
Yeah,
You have that P.
That P is sitting there.
So
It's not too far off. Why don't we just,
Yeah.
since L doesn't matter what side it is,
yeah.
just divide by that. So that doesn't seem too bad. We have a dp, and we have a kp, and a 1 minus p over L, and just a dt over here. He looks kind of lonely. Let's move the k over there. Doesn't
Oh,
matter.
that's what I had.
What? Multiply both sides by k. That k will not have to be over there, but you look so lonely, don't you think? So let's move the k over, because that's how I did it, and we can do it together. You will all end up with the same thing on the wash. All right. All right, with this one, however, we are going to figure out a way to get this to be integratable. And it's not as easy as it looks, but once we do our little trick, it will be easy. And that is partial fractions. Have you had those?
They don't sound fun.
I think you did. If you didn't, you just have to watch me. But you remember having partial fractions?
No.
I think I remember seeing them on your plate. All right, what we're going to do here is we're going to take this fraction here, the p, the dp, let's see, let's call it, we don't need the dp, you can just sit here. So it's like a 1. So this is the thing we have to switch to make it integratable. So 1 over, so come over to the side. And right now, as it stands, we can't integrate that very well. But if we split it up into what we call partial fractions, does this look familiar?
Sorry, John.
Does that look familiar? No!
Nope.
That looks familiar.
Is that like you just split them up?
You would do it.
I feel like I've seen that before.
All
Maybe
right.
not like last
Alright.
year.
You've been taking some summer courses?
Yeah.
Partial fractions is just a way to take a denominator that has several factors in it and split them up. And it's really pure algebra. So here's how it works. I want to find A and B. So once I do, I can integrate both. I can replace this expression here, which is right here, with this expression, which I can integrate simply. So you can write this down and learn it as I go. And once you know this, you're ready to just do some algebra. So whose turn is it? Gianni, I want you to multiply this whole thing by this expression.
Okay, so you would get, the first one, the p's would cancel out, and you just get 1.
Yeah, this one, if I'm multiplying both sides now, that's every term by this p, 1 minus p over L. So this times this times this. So in the first one, these cancel completely and gives you the 1. Here the p's cancel and read what's left.
1 minus p over L.
And the A. And then Gianni, this times this.
Would get you b times p.
Right. So now, all I have to do is find A and B, and it's really not that hard to do. Let's let P equal, I don't know what P, yeah, because I want to know what B is. Let P equal 0. So Morgan, once you've written this down to this point, I want you to substitute P equals 0 and solve it for A in your head.
Wait, what?
Let P
Okay.
equal 0. P is just a variable, so I can let it be something. So what if I let P equal 0? We get a 0 here,
It was just
and we get a
1.
0 here. So what's left?
Isn't it just 1?
Right. So we have A equals 1. All right. So that's cool. So we come back up here eventually, or I'll put it in there now. We know that's a 1. So on the second step, I don't want, so I can change this to a 1 as well. Now I want to find B. Can you think of something wise, Aaron, that I could let B, not B, I want B in the answer. I want to let P equal something else this time so that I can figure out what B is. What could I say?
You can't say 1 because A is already 1, right?
You could say, yeah, because we let P equal 0 before, so this time you want to let P equal 1. Let's try it. If it doesn't lead to anything, we'll try something else. All right, so what do we get here?
It would just be.
So you have, read to me what this becomes. We got 1 equals
1 times 1 minus 1 over L
plus
B.
B. All right, so if we solve that for B, that means we move this thing over here. What does B become?
1 over 1 minus 1 over L.
1 over, see this is not division
1.
because it's added to B. So to move this thing over, I subtract it.
Oh, okay, so it would just be 1 minus. Could you just subtract all of them together?
Yeah.
It would just be minus 1 over L.
Not minus either because when I moved it over.
Plus.
Right. 1 over L. Very good.
Difficulties.
All right, so that means up here B is 1 over L. And that's how I call a method called partial fractions. It's really something you should have learned from me in pre-calculus. We didn't get to it, but I thought that you used it in calculus last year. All right, so you can bear it.
Jokes.
So instead of having this, I'm going to write it like this. 1 over P plus 1 over L over 1 minus P over L is the exact same thing as what I've circled here. There's still a dP in my problem and a k dt. All right. Well, at this point, Brenda, do you remember what we always do? Can I erase the differential Can I erase the partial fractions?
Yes.
Alright, because I checked it, we got it right, so.
Miss Powell, it's been 10 minutes again.
Oh no, one problem.
Should I just stretch it out?
Yeah, that's alright, we'll go ahead.
Okay.
Alright, part 3. Did I miss it?